Herzlich willkommen zur Ringvorlesung heute, Ringvorlesung Technik und Umweltethik. And a warm welcome for our guest, Professor Dr. Teena Hassan. Professor Hassan will hold her lecture in English language, and that's the reason why I will also talk in English. And maybe if you hear me talking, you will not be afraid to talk in English too. You can choose whether you ask your questions or give your comments in English or in German language. That's up to you. And I think we will help each other to understand each other. Understanding each other, that is a very interesting and important topic in social interaction between humans. And maybe you know the story of the Tower of Babel from the Old Testament. And it tells the story when mankind only had one language. And so they were very successful, and they decided to build a tower to visit God. And God was not so amused, and so he made the people speak different languages. And then there was a lot of confusion, and the tower was never finished. So we see that the social interaction which makes us successful is depending on the language we speak. But today we will learn a lot about the communication between robots and humans, and then we will learn that it is not only the language, not only the meaning of words, which plays an important role. So Teena Hassan, she is professor for mathematical foundations of autonomous systems. And she studied a bachelor program in computer science and engineering in India. The motivation for her studies and her career was to improve living conditions of people by developing new technologies. From her opinion, technology should fulfill the needs of the people and not the other way around. This wish led Professor Hassan to St. Augustine. And from 2012 to 2014, she studied a master program, Autonomous Systems, at our Hochschule. The title of her master thesis is Dynamical Facial Expressions Estimation by Means of Model Fitting. And this thesis did not only receive the best mark, but also the prize for the best master thesis of all departments in 2014. She then worked as research associate at Fraunhofer Institute for Integrated Circuits, IIS, in Erlangen. And this research institute is a global leader in microelectronic and information technology system solutions and services. So the scientists work with customers and partners from the business and the public sector to develop, implement and optimize processes, products and systems. The international network of IIS and the research contributes to economic success and social well-being. So after that, she continued her research for the social human-robotic interaction at the University Bielefeld. From 2015 to 2020, she completed her doctorate at the University of Bamberg at the Faculty of Information Systems and Applied Computer Science. From 2021 to 2023, she worked at the University Bremen as a postdoc in Robotic Research Group. In 2023, she became professor at our university. The lecture title is Enabling Social Interaction Between Human and Robotics. And I just to remind what Professor Hassan said when I asked her to hold this lecture, she said that robots are coming closer to humans, either coexisting in the same physical environment or collaborating to complete a shared task. This makes ethical considerations inevitable in robotics research and development. So we are very happy that you are here, Professor Hassan, and I ask you to start with your lecture. The floor is yours.
Yes, thank you very much, Katharina, for the very nice introduction. And I really liked that you brought up the Tower of Babel. I think I can come back to it during my talk. And yeah, I'm happy to be here and give this talk to you about how to enable social interaction between humans and robots. So in this lecture today, first I will talk to you about what robots are, what makes them social, and what do they need to be able to interact with humans. As was already mentioned, I hold the lecture in English because that is the language in which I teach. But I understand German, so if you have questions, feel free to also interrupt and ask your questions in German. Okay? Good. So let's begin. Yeah, so first a question to you. What do they have in common? Yeah, you can tell. Yes. They are alive, okay? They are living things, yes. Individuals, yes. Yeah.
I think every species in the photos has a face.
Yeah, very good. It has a face. What else? What can they do? Can they do something? Yeah.
All of them have their own abilities, behaviors of eating, of living, of sleeping, for example.
Yes, so yeah. They need to act in specific ways, yes. Any other observations? Okay, good. Then let's go forward. Now, what about these? What do they have in common? I guess yeah.
They are all powered by electrics.
Electronics, yeah, gives them the energy to function, yes. That brings them alive, right? Yeah. First you, then.
They serve the humans.
Yeah, they serve the humans, yes. So they perform certain tasks that are beneficial to humans. Yeah, any other observations? So in the previous case, you said they have a face, yeah?
They are robots.
Hmm? All robots, yes. Yeah, that's right, yes.
I guess they all operate based on a program code.
They're driven by software. Unlike in biological agents, we have neural circuits, we have the brain that is running programs for us. Yes?
They're all autonomous.
Ah, interesting. Yes, they are autonomous. What do you understand by autonomy?
It's no person or no other program, that the program has been programmed into these devices
Yes,
and operates.
them. Yeah.
Somebody is
Yes.
pushing the button and the other sets it.
Yeah, that's a very good observation. Robots are autonomous, or at least they're intended to be autonomous, that they function on their own without the intervention of humans. So just like biological agents, they are individuals, you said, right? They also act on their own, yeah? So as you can see, in both cases, in the first set of pictures, we had biological agents. In the second set, we have artificial agents. And these artificial agents here are special because they have a physical body, right? They exist in a physical environment, and if they act in the environment, they can change some things in the world, right? In the physical world. So we also have other types of artificial agents called virtual agents. So they are the ones you see in games, maybe AI-powered games. You have non-player characters fighting against you and so on. So they are virtual agents. So they exist in a virtual environment. They also act in the virtual environment. they have a body, but it's a virtual body, right? So this is what distinguishes robots from other artificial agents, because they are physical and they can exist in the same physical environment as humans. And that is what brings an added level of ethical complexity to the whole thing of human-robot interaction. So, in general, we can say agents can be described using the sense, plan, act paradigm. That is, every agent has sensors, right? So you said the biological agents had a head, a face, which is equipped with sensors, right? With eyes, with ears. Your skin is also a sensor. It helps you to get haptic feedback in the environment, right? So you have different types of sensors. So artificial agents also have sensors to perceive the environment, extract information from it. And using this information, it can plan certain actions to achieve goals. So it can reason about the world. It can think that, okay, there is a glass here, it's filled with water, it can be picked up. Yeah? So if the robot here was supposed to bring me a glass of water, it has to know that, okay, its hand is empty, yeah, it doesn't have anything in the hand, and it should see the glass, right? It should know where the glass is. It should go or walk to the glass and pick up the glass, bring it to me and give it over to me. And after it gives it to me, its hand is free again, right? So it needs the sensory feedback to be able to understand whether its actions have been successful or not. And in the planning stage, it knows what is the state of the environment, what is the goal, and it can plan a set of steps to get there. It is pretty much like we humans also do. When we cook, we know the steps to be followed, right? So in the same way, robots can plan a sequence of actions, and then it can act in the world. So acting means moving parts of its body to make changes. Yeah? It has to walk, so it should move its legs. It should move its hands. It should grasp to be able to lift the object and so on. So planning gives you an abstract set of actions, and acting actually executes those actions. And when an action is executed, again the environment changes. So maybe once it grasps and lifts the object is not on the table anymore, and the hand is not free, right? So these are things it should again understand from its sensors, that the actions it performed had these effects in the environment. So yeah, a robot is defined in this way, that it is an autonomous system. It exists in the physical world, is very important. It can sense its environment. It can act in the environment to achieve goals. Okay, now with autonomy is an interesting concept. So I can't find the person who asked me. Here. So autonomy, technically, we think it is full independence, right, from humans. But in reality, there is a set of different autonomy levels. So you can go from complete teleoperation until full autonomy. And even when we say full autonomy, it is very task specific. It's not like humans who can be autonomous in any situation. No, we have vacuum cleaner robots, right? They are autonomous, but they can only do certain things autonomously. Can walk or move around, suck the dust and so on. But if it gets stuck in cables, it's not autonomous anymore. It needs somebody to intervene and help and free it, right? So autonomy, when we hear the word, we think that it equates to a highly intelligent system, but it's not the case. It's usually independence in executing very specific tasks. Okay, so we have seen the definition of robots. Now, where do robots find application? So, of course, in many different fields, almost every domain in the real world, in real life, especially in healthcare and therapy, in education. We have robots that provide entertainment just for fun, yeah, like toys and pets. We have telepresence robots that allow people to connect remotely and then move around, navigate and manipulate in the environment. We have also industrial applications, military applications, or even robots that help with tasks at home and so on. So depending on what purpose the robot is created for, you can see that there are different types of morphologies. So you have different forms and shapes and sizes for robots, right? So something like this, which looks like, let's say, an earthworm or a snake, yeah, it can be used to go through pipelines, inspect pipelines, or clean sewage, inspect sewage canals, and so on. Yeah, so it's very flexible, yeah. And something like this in the middle, the Aibo, it's a robot dog. It's intended as a pet, as a companion. So it's modeled in the form of an animal, so zoomorphic shape. And then we have this one here, Ayla. It is looking, it's big, yeah, it's a human size and looks also abstractly like a human. And this was created for assistance in International Space Station. So where there the robot has to maybe operate the panel and so on. So there, that was the application. So depending on the scenario and the task and the purpose, we have different designs, physical designs for robots. So what do you think? Which of these applications would require social communication capabilities? Yeah. Yeah, the dog. Yeah, it has. Yeah, and which of where do you find the dog here? In which domain?
Maybe at first entertainment, search
Yeah.
and rescue, public service, home and workplace.
Okay. Yeah, lots of places. Yes. So in reality, whenever a robot works together with a human, we need some social communication capabilities. But predominantly, social interaction is there in healthcare, therapy, education, and entertainment. That's the primary area where this field of social robotics developed. Okay, so now I have two videos. I think you have already done a lot of background research. You looked at different types of robots, robots in education, therapy, and so on. So I will play two videos, and then after that, we will get into a discussion about what is a social robot and so on, okay? So let's start. So let's see how what robot is used in the scenario and how it is intended, what effect it did have on the children. Yes, so that was Kaspar, one of the first robots that was created to interact with autistic children. And the advantage that was said was robots can repeat the same thing again and again without getting tired. And they have a very simplified appearance, right? They don't have all the sophistication of a human face. So they have reduced expression capabilities, and it is easier for children to read them. And so this I think this kind of research started in the beginning of 2000s, and it is still going on. So at our Hochschule, in our institute, we also had a project, Migrave, where we also created socially assistive robots for autism, for assistance with autism therapy, and helped children learn specific behaviors and specific vocabulary and so on. I think I will skip the second language video in the interest of time, but it is a similar situation where we have a Now and a tablet, and the Now acts as a tutor trying to engage the child in the learning of language through a game. So, therefore, as you can see, social interaction or social robots need specific types of capabilities. It needs the appropriate sensors to be able to read social signals from humans, and it also needs appropriate modalities to show social signals to humans, right? But the good thing with robots is that in addition to all these human-like modalities of face and body movements, it can also rely on electronic or artificial modalities like a tablet. It's an added way of interaction with humans. So some robots come then with a tablet as a face and so on. So you find a lot of different combinations. And of course, speech is a very important modality for interaction. So the robot should be able to understand speech and also produce speech. Now at the planning stage, this is, let's say, the decision-making layer. So it needs a lot of models that allow social cognition. So it should be able to understand the user, model the user, predict the next action or intention of the user, and it should be able to engage in dialogue or conversation with the user. So it should understand all the techniques and constructs involved in dialogue, like turn-taking, back-channeling, meta-communication, and so on. So it needs to be able to talk in a context-specific way, in a polite way. It has to respect social norms of communication, right? So all of that is taken care of in the planning component, let's say, and this is really complex. So not all robots come with all these capabilities, yeah. So communication is one of the thing, then understanding emotions of users, ability to express emotions, right? Kaspar was able to show happiness and also kind of fear and sadness, right? And sometimes personality and traits are also important. Maybe we want a friendly robot for a teaching setting. We want a proactive or extroverted personality when it comes to entertainment use case and so on. So we can have personalities in robots. We can have complex things like theory of mind, which is something children from the age of 5 possess. So we can always predict and model other agents in the environment. It might even be able to learn new skills through interaction and establish, maintain social relationships over time. So these are all sophisticated social capabilities. But like I said, not all robots have all of this. Therefore, depending on what cognitive capabilities they possess and depending on how they are perceived by users, we have different categories. So as you can see, we perceive robots based on the external behavior that it shows, like how it looks, how it talks to us, and so on. But it's not necessary that a robot that we think has high social aptitude also has high social intelligence. That's not necessary. Yeah, so here I have a robot that is pretty much doing nothing, but I already got a lot of questions about the robot. And then the first time I saw it in the lab today, it was lying flat in the cupboard. So they said, yeah, it's sleeping. Yeah, and then you take it out, and then you're afraid whether the head would bend too much. Yeah, but it doesn't make sense. But you treat it somewhat like a child, right? And then there are scars on its head, and you don't say, oh, there are scratches. You say, oh, he got injured, yeah? So you attribute a kind of human likeness to the robot, which is something we call anthropomorphism, right? We attribute personality to inanimate objects or non-human objects. So we treat our cars like our pets and very precious possessions, right? So we talk to them and so on. So yeah, so even when a robot doesn't do anything, it still can evoke certain responses. And then we have socially evocative robots, and on the other end of the spectrum, we have socially intelligent robots, which have all the deep concepts of social intelligence implemented, and such robots are also then perceived as having high aptitude. So when you hear the term social robot and social interaction, don't just believe immediately that it can do everything. Be a bit more critical and try to find out what is it. Is it just having a social interface that just talks to you through speech modality, or can it really understand social interaction? Can it understand what is meant by dialogue, how to plan a dialogue, and how to manage a dialogue? Yeah, so be a bit more critical. So here I have one more video that I want to show you, and here I want you to observe the different modalities through which the interaction takes place. Is it just speech, or is there more to it? Okay, so observe it from the point of view of the person and the robot. So you have two agents here. Yeah. Yeah.
So I think I saw in the first clip when the robot gets touched on the forehead, it opened its eyes, and you could also see a movement on the arms.
Yeah.
Arms. To me, it was a bit similar to a dog waving its tail, which is a symbol of happiness. Yeah, and I think the robot also made like a noise in a high tone, which seemed like friendly to the human being.
Yes, very good. Anybody wants to add to that? Oh. Okay, yes. So here you can get to see a lot of different cues. So the robot here is a baby seal robot, just mimicking a seal, and it can respond to touch. So there is a modality, a haptic modality here. So touch is it can respond to touch. So there is different types of touch. Yeah, you can stroke, or you can maybe hit it a bit hard. So it has different responses to different stimuli that it perceives. So so this looks somewhat like a reactive response, right? If you stroke it on the head, it might make a voice, a noise, and wag its tail and so on. So there is not much thinking, but there is a response, and it stimulates emotions in the person, right? The person laughs. And you can also see that time plays a role here in the interaction, right? In the case of the lady here, she was distrustful of the system. She was afraid in the beginning. So you saw that there was more distance between the robot and her, right? So that talks a little bit about, okay, I don't feel safe yet, I don't trust it enough. And then she interacted with it, and when there was enough trust and she liked the robot, she pulled it and she hugged it. So the robot is now in the intimate space, right? So it is as close to her as possible. And that happens only when there is trust. So the proxemics, the distance between the human and the robot, as well as the times that is spent during the interaction, they also carry some meaning about the relationship between the human and the robot. And over time, you can build change the relationship through continued interaction. It also means if things go wrong, your trust will break and you won't use the system. So reliability of the technology is also a key factor in acceptance of the technology. Okay, so maybe quickly a word about model of communication. Yeah, so from an engineering point of view, electronics point of view, we always talk about communication as sending and receiving messages, right? You send a text message on WhatsApp, somebody receives it. So it's more like a linear model, right? But human-to-human communication is not linear. It is cyclic. So there is nothing like sender and receiver. There are only interpreters, because we are always interpreting the other person, even if they are not actively speaking. So, right? So I see your faces, some are nodding, some are smiling, some are looking elsewhere. So I know, I read what is going on, right? Some are engaged, maybe some are taking notes, and so on. So we interpret our interaction partners continuously. And even when we don't speak, we are sending out signals. So this is something interesting that Václavic and colleagues said. We cannot not communicate. So here, this is a robot that is sitting here. It's not powered on, but still you look at it. Maybe you thought, what can it do, right? Why is it staring at me, and things like that. So this is something that is difficult for robots to understand, that not speaking and not talking also has a meaning, right? And it also doesn't know yet that when it doesn't talk to a human, also it is conveying some message to the human. So this is very difficult to model, because how do you interpret silence? I don't know. It's very, very context specific, and context is also very hard to model, right? So interaction partners, communication partners continuously send signals. Sometimes it's verbal, sometimes it's non-verbal, and together they create the meaning of the communication. And the interesting thing is that each agent has different codes. So even if they speak the same language, they can still have a different set of vocabulary, and they can have a different set of semantic interpretation for words. Some words may be related to some experiences that might trigger certain other moods and feelings in the recipient, right? So each person has codes, linguistic codes, psychological codes. They may have different socio-cultural contexts, and we interpret messages using our codes, and when the codes don't match, there is miscommunication, right? And then when there is something like that, we switch to so-called meta-communication, where we stop talking about the subject and talk about communication itself. So things like clarification requests. So you would say, okay, I couldn't understand what you said. Can you explain again? Yeah. So that statement, can you explain again, is a meta-communication. It doesn't add any new information. It just says, please repeat what you said, right? So these are all things that happen continuously, and it is said that when a communication fails, it's not the fault of one of the agents, it's the fault of all the agents in the communication, because the meaning is co-constructed. So, so it is the duty of all participants in the communication to establish a coherent exchange of information. Yeah, so robots should be aware that the human is constantly interpreting the signs sent or not explicitly sent by the robot, and this could influence subsequent interaction. So if it, so in this case, it is not switched on. So everything I told to this robot in the beginning, it has no idea about it. But it will change the way I see the robot when it starts functioning, right? And this is not available to the robot system. For the system, it would be a first interaction, but for me, it's not the first interaction, right? So this is something the community has not looked into. Yeah, I think I mentioned this already. So here I have one small example from a project that I worked on, which looked into creating software architectures for social robot interaction. So in the case of Paro robot, we said it was very reactive. So to certain stimulus, it responded, right? But interaction has different levels. So you can have reactive interaction, reactive behaviors where the robot would say, would function based on certain rules. So it can be told whenever you see a face, smile. Yeah, it could be a rule programmed into the robot. But it can also have intuitive behaviors. So intuitive behaviors are behaviors learned over time. So maybe it knows the preference of the owner, that the owner likes to be greeted always in the evening when they come home, right? So then you have a higher level of processing, where it has to recognize who the face belongs to, and then look at the memory and say, okay, what does this person like? And this person likes to be greeted. Okay, then I greet. Yeah. So this is more like the intuitive or associative layer. And then comes deliberative layer. So in this project, we built this robot from scratch. So it's a startup in Munich, and they called Naval Robotics. So they built this, and they were leading the consortium. And we at Bielefeld created the software architecture as part of this project. So yeah, this robot was supposed to be a lively robot. It had its own needs. So when its joints get warm, it wants to rest. When its battery is low, it says it needs energy. Sometimes it's very proactive. It has a need to entertain itself, so it might play music on its own, or it might engage in a dialogue proactively with the human when it wants to have a social contact. So in this case, we come to the problem of trade-offs between need of user and need of robot. Let's say the user is coming home and is very happy to see the robot, but the robot is almost drained of battery and has to rest and recharge. Then there is a conflict, right? So it cannot serve the need of the user, the owner, which it should be doing, but it has to then prioritize itself, right? So how do you resolve such conflict situations? So that needs more deliberation, right? It has to take the context into account. It has to take its utility functions into account, and it has to make decision what is the right strategy. Maybe it says, engages in a brief conversation, and then says, okay, now I really need to recharge, otherwise I will switch off, right? Instead of just going away. So some trade-off needs to be found, and in such dynamic and new situations, it has to think more. Yeah, so it has to deliberate. So reactive is often the fastest, deliberative is the slowest mechanism. And the challenge here is how to put them together. Maybe the reactive thing says something and the deliberative thing doesn't want to do that, wants to do something else. So how do you override, how do you smoothly transition between different behaviors and so on is a technical challenge in the field. But today, robots no longer exist in isolation. So it's not just social robots that need social skills. Robots now work closely with humans in every field, right? So in the industrial context, you may have robots helping you to assemble some thing together. So here you see a PC being assembled together. So the robot has to prioritize safety of the human, right? It shouldn't hurt. So if it sees a hand in its workspace, it should stop, right? Or maybe it should understand the gestures. So it might say, yeah, give me the screwdriver, yeah? And it should know that screwdriver should be put in the hand, right? So gestures have meaning. On the right side, you see a space robotics context. I think this is a nice video I should show. This is a bit hypothetical situation. Maybe I play it faster. So, yeah, so this is a scenario that was part of a project where they tried to model different interaction contexts or scenarios between humans and robots in a space robotic setting where a robot is supposed to help a human astronaut build a base station on some faraway planet. Yeah. So here you can see that the robot is also human-sized, right? So here they work as a team, as a peer, and it has to do also heavy tasks like lifting solar panels and heavier objects. That's something a robot like this cannot do, right? So it was designed for the task. And it also, there was not much communication, but still it had to understand that pointing gesture has a meaning. It means robot should look at an object and establish so-called joint attention, right? It has to understand speech commands, so there is no conversation like in social setting, no dialogue like a companion, but it should be able to understand speech commands to enable natural interaction, right? So what I mean to say with this is that the scope of social interaction is nowadays no longer limited to social robots for education or therapy. It is part of almost every application domain in some form or the other, because we are working with humans. So the role of the robot has changed, right? So you have not just robots working for you. In the telepresence case, the robot is you. It's acting as you in some other space, right? In collaborative case, they are working with you to build something. In the case of exoskeletons, you are wearing a robot and it is a part of you, right? So there are different roles, and that means there are different ethical issues also that come into picture. And especially with vulnerable groups, we should be careful. So like I said, there are different problems. You can create expectations that may not be true just because the robot is designed in a way that doesn't suit the task. Maybe you trust the robot more because it has a body, yeah, you attribute more human likeness to the system, which it may not have. Maybe it's just the facade that looks like a human. Maybe you made a social bonding with it that you forgive mistakes, errors, and failures after that bond has been created, right? Which is sometimes problematic. And then these companion robots that motivate you to go for a walk, yeah, that can get too much sometimes, that it persuades you, puts pressure on you, and to some extent compromises human autonomy for decision making. Maybe the person just doesn't want to do and should be allowed to not want to do anything, right? Then what I find interesting is violation of privacy. So the robot might have, especially in home settings, might have access to information that maybe other guests who come to visit you should not have access to, right? So there is a risk that robots may inadvertently compromise your privacy. And what I also find really problematic is that we might transfer the skills we learn from human-robot interaction to human-human interaction. So we know that robots never get tired. It can repeat the same thing 100,000 times, but you cannot expect that from a human, right? So the humane side might be affected when we interact too long with robots. But there is no long-term studies that have been sufficiently done to investigate this problem. So anyway, I personally believe that if we have such social robots, it should be limited and very concrete and precise in its scope and application. So I show you one video where you can really see some of these risks, okay? So it is Einfügen, okay. Yes. So here you can actually see the system has access to the album, it has access to email and all of that. And if somebody else comes into your room, maybe somebody wants to repair something at home and to paint the wall or fix a tap, yeah, they can easily get access to this, and or maybe somebody can hack into the system and steal all of this information, right? So this is really something we have to take care of. Of course, it has benefits for people who are living alone, but we have to be aware of these problems. So I just want to say this has redefined now the meaning of autonomy. So now we are no longer looking at robots acting without humans, but robots acting together with humans. And for that, we need not only high autonomy, but also high human control, which means the robot should be controllable, predictable, and understandable to humans. And in this way, we can empower and enhance human performance. So there are different aspects to it, which starts with intuitive interaction, and it goes over to learning from humans, adapting to the humans' preferences, understanding their needs, and also, most importantly, explainability. So it should make its decisions transparent to the humans. It should be able to say why it made some decisions, why it's doing some actions. Yeah, so safety and also, of course, all the ethical aspects need to be addressed. Yeah, so I had one last video, I think, but it's okay. I can stop here. Maybe I can share the link later. So this video then shows how robots explain its own behavior and how things can also go wrong there sometimes, yeah, due to technical difficulties in speech recognition. It may not understand that you wanted it to explain something, and by that time the time is over and it's not doing anything, and then it would say, yeah, I'm doing nothing. It would be the explanation it gives you. So here you can see that she was able to ask different types of questions. So what are you doing? Why are you doing? And the why could be asked multiple times, and each time the answer was a bit different. So it could say its intention or its need. And but you also notice some issues with the interaction, right? Sometimes it didn't pick up the things that were spoken by the person. So questions had to be repeated, or it was just not responded to because it was not taking turns in the right way, right? And it kept on talking and talking even though the person wanted something else. So the actual social interaction should also take these feedback into account, which is a very complex task. And like we saw in nonverbal modalities, chronemics, so the time involved in interaction says a lot. So it can mean the robot is not interested, or maybe it is not efficient, right? It's not capable, it's not competent, and so on. So it can also affect the acceptance of that technology. Yeah, so that was the talk about. Thank you for listening.
Thank you very much, Teena. Yeah.